have an outer and inner. It's going to kind of kill you guys. So what I'm going to do is I'm going to move this guy over again. Square root of 3 sine of x is equal to cosine of x. And I'm going to square both sides again. Let's use purple. Let's use purple this time. We have to use purple in a long time. So square root of 3 times sine of x times the square root of 3 times sine of x is 3 sine squared of x is equal to cosine squared of x. Now at this stage you could change everything into sines and cosine, cosines or sines, and then try to solve that out. I would rather not do it that way. You're gonna have a little bit of a problem. At this stage, using my intuition, my gut, or experience in this case, I'm going to divide by cosine squared of x. And so when I divide by cosine squared of x, I get 3 times tangent squared of x equals 1. And then, do you notice how I changed to sine squared over cosine squared? You could have actually, if you're not familiar, changed to 1 minus cosine squared and then try to work it out that way too as well. I might work it out that way for you, but this is one easier way. So I divide it by 3, get rid of that 3, and I take the square root, and I take the square root. The square root squared is going to be tangent of x. Square root of that is equal to plus or minus 1 over square root of 3. From this portion right over here, I can use the reference angle now. Here's my x, here's opposite, adjacent, and that's 2, 1, root 3, and 2. X is going to be 30 degrees, 30. So one's a positive and negative. At quadrant 1, it's going to be 30 degrees. Quadrant 2 is going to be negative. It's going to be 180 minus 30. Quadrant 3 is going to be 180 plus 30. And quadrant 4 is going to be 360 minus 30. That's equal to 30, 150, 210, and 330 degrees. And that's your final answer. Not quite, because we squared both sides, so we have to check for extraneous solutions for these, okay? So let's start with the original equation. Let's do sine of 30. I'm just going to plug it in here. Sine of, let's write it out. Root 3 times sine of 30 is going to be 1/2 minus cosine of 30 is going to be root 3 over 2. Does that equal 0? Question mark. Yes. Check. 150, root 3 times sine of 150 is going to be positive 1/2 minus cosine of 150. So we got the minus here, cosine of 150 is going to be negative root 3 over 2. Does that equal 0? No. No. Let's check this one right here, 210. Square root of 3 times the sine of 210. Sine of 210 is going to be negative 1/2 minus cosine of 210. Cosine of 210 is going to be negative root 3 over 2. A negative, positive, does that equal 0? Yes. Check. And we're going to check the last one. Radical 3 times the sine of 330. Reference equals 30. It's going to be 1/2. Negative minus cosine of 330. Cosine of 330 is, cosine is positive in quadrant 4. Cosine of 330 is going to be root 3 over 2. Minus something does not equal 0. No. So these are your two final answers. Oh, they want all solutions in radians. So it's going to be, this in radians is going to be 5 pi over 6 plus 2 pi k. And 210 degrees is going to be 7 pi over 6. So I remember my pi's plus 2 pi k. Let's check our work on that. Number 14. Pi over 6 plus 2 pi k. I believe I might have got a misprint on that. I'm not quite sure. Let's say it's pi over 6. This, instead of 5 pi over 6. Is that right? Let's see. How can it be pi over 6? Let's do this one. Sine of pi over 6. Yeah, I'm sorry. It should have been pi over 6. No. Circle the wrong ones here. Should have been this one and this one, right? So it's going to be pi over 6 plus 2 pi k. And this is the correct one. That's 7 pi over 6 plus 2 pi k. Circle the wrong one. What I like to do is I like to point to the answers as I go along. I know most of you, while you're taking the test, go, this is my answer, and then you write these as your answer. And you get it wrong. One of the ways to avoid that is point to it as you're going along. I should have heeded my own warning on this one. Smack. Sad face. Okay. Next one, and I'm trying. I believe 16 and 18 is the last two problems we're going to be doing. Okay. Number 16. Let's do sine cubed of 4x is equal to 1. And we're going to write all your answers in radians, and you want to find all solutions. Well, the first thing we're going to do, 4 is going to kill you, but we take the square cube root of both sides. So the cube and the cube root cancels, you get sine of 4x. The cube root of 1 is just 1. It's not plus or minus. Only when you do square roots do you put plus or minus. Think about that. If you're not sure, work it out. Okay. 1 is equal to 1. 4x is equal to 1 at pi over 2. How are we going to do all solutions? We're going to do one round of that. Pi over 2 plus 2 pi. Pi over 2 plus 4 pi. Pi over 2 plus 6 pi. So you have the 4x equal to pi over 2. Pi over 2 plus 1 round, plus the third round, plus the fourth round. So that's the first round, second round, third round, fourth round. I'm going to check to see how they did that on number 16. They put it in a really elegant form. How did they put it in such an easy way? Okay. Oh, for all solutions, we're not going to do it this way. For all solutions, we're just going to add 2 pi k. Remember that, guys? Because we're going to do all of the round, not just for 4. So 4x is equal to pi over 2 plus 2 pi k. And what I'm going to do is I'm going to divide it by 4. Divide by 4, divide by 4. And what I end up with is x is equal to pi over 2 divided by 4 is pi over 2 times 1/4. This is pi over 8 plus 1 and the 2 cancels. You get pi k over 2. Just take that matches. Pi over 8 plus k pi over 2. Oh, perfect. Just right. Okay. Give them what they want because it's your problem, not theirs. 18. So you have 4 cosine squared of theta minus 4 cosine of theta equals 2. What's your problem here? Well, you got a quadratic. Let's use pink this time. There it is. There's a 2. It's quadratic in nature. So what you have to do is you have to move it all over, set equal to 0. 4 cosine squared of theta minus 4 cosine of theta is equal to negative 2. Minus 2 equals 0. Let's see if that's factorable. Oh, on number 18, find all solutions to the nearest tenth of a degree between the interval of 0 and 360 degrees. So follow the directions. I want all solutions. Okay. At this stage, this is not going to be factorable. I can tell you right away. But you can try to factor it to your heart's content. Good luck on that. So I'm going to use the quadratic formula on this one. Here's my A, here's my B, here's my C. And so instead of X, it's cosine of theta is equal to negative B, which is 4 plus or minus the square root of negative 4 squared, 16 minus 4 times negative 2, all over 2 times 4. I'm going to do that on my calculator. Where's my calculator? Give me about 3 seconds, 5 seconds, excuse me. Sorry about that, my calculator was on the other side. Remember guys, I have a little program. You can download these programs if you want. Try to Google it. Programs. It's a quadratic formula. Like I said, I made this one on my own. Get your own. Sorry. Negative 2. And it's going to be cosine of theta is equal to 1.366. If I simplify that, cosine of theta is equal to negative 0.366. If I simplify that. Okay? So that's created by JQ, that's me. All right. So we know that the cosine of the angle cannot be greater than 1, so we cancel that out right there. It has to be between, cosine of the angle has to be between negative 1 and 1. So what we're going to do is we're going to make sure we're in the right mode. Check your mode. I'm in radians. I want to go into degrees because they want in degrees right here. We're going to take the cosine inverse of negative. I'm not going to do negative. Just go 0.366. Okay. It's going to be approximately, that's theta hat, 68.5 degrees. Okay. Make sure you're in the right mode when you do this, guys. All right. That's our angle. When is it equal to negative? It's going to be in quadrant 2 and quadrant 3. So it's going to be 180 minus 68.5. It's going to be 180 plus 68.5 degrees. 180 minus 60 is 120. So it's going to be 115.5 degrees. And 180 plus 60 is going to be 240. So it's going to be 248.5 degrees.